So anytime we have a function defined by a integral, and we want to find the derivative of it, we have to look to the definition of the integral. So the integral from a to, let's say, b of f of x is going to be equal to, and I suppose I should have a dx, capital F of a, or sorry, b, minus f of a. Well, now what if we, let's say, had a function in one of these bounds? Well, it'd be the integral from a, and in this case, let's just call this g of a of f of x dx. Well, the g of a is now going to take the place of the b, so we get f of g of a minus f of a. So now, what happens if we take the derivative of this? What if we want to find the derivative of this, as this is a function? And I suppose, yeah, that should be fine. Because we're going to say that we're taking the derivative with respect to a. So we take d over dA of both sides. So we get the d over dA of the integral from a to g of a. Kind of bad wording here, but let's say this is a constant. That of f of x dx. Well, if we're evaluating f at a point a, that's a constant, so we don't have to worry about it. We'll have to use the chain rule for this. So we get the derivative of f is going to be little f of g of a times by the derivative of g, which is g prime of a. Now we can use this formula here to determine that whenever we do take the derivative of g, the derivative of the integral from a to sine of x, natural log of t plus 7 dt, we don't even have to evaluate this integral. We know that this is going to be the same thing as natural log of whatever function's up here. So sine of t, alright, plus 7. Now this is the inside function, but now we have to multiply it by the derivative, which is going to be cosine of t. And this here is our solution to the derivative of g.